I'll continue where I left off last time, and we had just been looking at gregexpr. I say that like I know how to say it. I'm not sure how people say that one, but it finds just the first matching, and we found this with E, and it found just the first matching of E in. And since we're starting this as an episode, I'll go ahead and do text, since this is the vector of two character strings, and there are clearly several E's in there. So the function to find all of them is, oops, I'll do lowercase, since I believe it is case sensitive. And this returns a list with the character location in each list being each position in the vector. So there are 1, 2, 3, 4, 5, and if we wanted to know the number, we could count those up. Since I wanted to try this with one of the words, say this, I'll do it how I tried it first. And I was expecting it to be there to be two of them, since there's this, and it returned 1, and it's a length of 4, and then the -1 means it didn't find it in the second one, and I realized, of course, it is case sensitive. So I will, oops, don't want to do lowercase either. If I just take it off, it obviously, if it were a longer corpus, find more of these, but just to test it out right here, then we can see that it finds it starting in the second location, this is the first example sentence, and in the sixth location. So we see that it occurs once in each of our example sentences. Since it is returning lists, if I want to access just one of those lists, then we'll do it this way. I'll go back to the E, since there are several occurrences in this one. Then it's the same way that we access a list with the double brackets. And so then here we have just the one list. I was curious as I was doing this how the individual lists, these sets were being treated, since it looks like 3 vectors, but I know that they're attributes, whether they were being treated as vectors or lists. And when Gries talks about it, he says that this first set of data right here can be treated as any normal vector. And that, from what I can tell, that seems to be true. But what I tried, and I'm not sure that it really answers my question, but if I try this to see if it is a vector, we'll run this, it says that it's not a vector, and I didn't put it up in here. Maybe I will do that. It shows that it's an atomic, and it appears to be a vector, but it's a vector, or it's whatever it is with attributes. So I tried it. Is it a vector? Is it a list? And it also says false. So you can treat it as a vector, and we'll just leave it as that. He also suggests if you want it to have it as just a regular vector, you can unlist it. I guess I don't need the whole is.vector. So we can unlist it. It gives us the whole thing. Oh, if we unlist just the first element, then we have it. Well, that makes me wonder, what if we just I don't know if that will even work. it's the first, that was the first list still. So to unlist it, we do have to do that, and it gives us it as a vector. So that was one suggestion to be able to get rid of the attributes if we want it just as a regular vector. Another way to get rid of the attributes, if we want to do that, he suggests using sapply. And so sapply to the whole thing, and with that we need to have the list or vector that we're applying a function to, and then applying the function c. If we want to see what the c function is, it's combining the values into a vector or list. And so it appears to be combining them. I don't know, I can't really say. I can see what it does, but I'm not quite sure how it's happening. So if you know how it's happening, I'd be interested to see. But the result that it gives is still a list, but it is each vector without the attributes. So if we do this, we have each of the occurrences of E where they start. Well, it's just one character, so I guess the start doesn't matter so much. But each place they occur, separated by each position, each vector. We have the same thing as, where did we have it? So if we went individually one sentence essentially at a time, we did the unlist here. So the final way that I'll look at is the final unlist, looking at the whole expression rather than just the first element of the list. And this combines everything all together in one vector, and you can see that the 16 starts right here, and that's where the second sentence starts. So you'd have to have some way to identify that, but you still have it all in one single vector. And that's where we will end today. Actually, never mind. I see that I have just a little bit left, and it has to do with the attributes. So let's do this here as well. This would be how we can access the lengths from the attributes. So if we continue on with the same expression that we've been doing, we have attributes, so I still have it copied here. So I'll paste it. If we use attributes, then it returns null. So it doesn't actually tell us what the attributes are. So to actually get at the attributes, I'll go ahead and just make a change to this. We would need the attributes of the first item in the list rather than the full list. So when we do that, we see that the match length, so for each E that it matched up, it was just one length. And if we wanted to unlist those, so if we wanted to be able to access them just as a vector, copy this. We have it as just the first set. Then we can see the names, but they're all listed. Actually, I find myself wondering if this is now a vector because it doesn't look like a vector, but it is. Okay. As seems to be true, there's multiple ways of doing almost everything. So another way is using the using this function. I'm already typing, so I'll go ahead and type it out. And so it's putting in the expression that pulled the list for us, and we're telling it we want the attributes. We don't need it as a function. And what are we missing? Oh, so we still need just the first set. No. Oh, it's not attributes. We need the specific attribute that we want, which is match length. We're not saying attributes generic. We're saying the match length attribute. So we're telling which attribute we want. And then it gives us clearly just the vector, and we know what that vector is. We can also do, again, sapply. Trying to decide if I want to do just the first list. Probably don't have to. And we want to find the attributes. So this should give us all of them. And I found myself, as I was looking at this, I wasn't quite sure what was actually in match length, and had to look at it a little bit closer. And the simplest, this is probably not the simplest way, but this is the way that it worked in my brain, is to put it in a list variable, and then to see what was the first element. And I can see that the first element of that list is all the lengths. So why it doesn't display it here in the R console, I'm not sure, but it is apparently all there. Oh, I should do comma 1 so that we can see the whole column. And if we want to see the second one as well, we can see that there are 6 of them. So the final ways, and this will be 2 final commands, I think. We can do sapply, and our search for the E and the function that we're going to apply throughout that whole list. And when we use that particular function, the trib, attr, we have to give it the attribute that we're looking for, match length, and then it gives us the list with just the lengths. And then finally, if we want all of that together, then all we would do is unlist it. And then we would have a full set of all the lengths. And that's where we'll end today.